I think that probably most people who don't have a science background either don't know or have forgotten the difference between atoms and molecules. And why should you want to know? Well, perhaps the best reason is just curiosity. You've heard those two words, they've been kind of interchangeable, and what is the difference? Or maybe another more practical reason is that there are people out there who will use what you don't know about basic science to sell you things like magic medicine, things that cannot possibly work the way they say they do.
Also, death rays come in two kinds: disintegrate to atoms and disintegrate to molecules. They cost very different prices, so check before you buy. Give it back. One man.
Anyway, as I was saying before I was so rudely interrupted, if we're going to understand the difference between atoms and molecules, we're going to need some pretty special equipment. And this is the high voltage electron microscope at Kyushu University. It uses voltages of 1200 kilovolts to see down into the very insides of materials. It can look several layers of atoms below the surface and tell us what is going on there. And this is a box of Lego. You see, atoms are like pieces of Lego. Just like individual pieces of Lego make up all the models and the houses and the spaceships that we make, different shapes of Lego piece are like different kinds of atom. So we can group these pieces of Lego together, but what makes atoms different is not their shape. Basically, they're all round. What makes them different is how many protons they have. Now, we don't need to worry what a proton is just now, except that atoms have somewhere between 1 and 90 protons. They can have more, but only if we make them artificially. And atoms of the same kind are atoms of the same element. So for example, if an atom has 1 proton, then it is an atom of hydrogen. And if an atom has 2 protons, it's an atom of helium. 6 protons make it an atom of carbon. 8 protons make it an atom of oxygen. 3 protons make it an atom of lithium. And 26 protons make it an atom of iron. Now, something else which is a little bit handy is that we can have the same shape of Lego with different colours. And with atoms, this is a bit like atoms of the same element. For example, our atoms of hydrogen, but different isotopes. Except the difference with isotopes is they aren't different colours, but they're different weights. So for example, we might have an atom of hydrogen, and most atoms of hydrogen have a weight of 1. We don't need to worry 1 watt just yet, but it has a weight of 1. But there's another kind of hydrogen which has a weight of 2. We might call it hydrogen 2, but usually we call it deuterium. And then there's another very rare form of hydrogen that has a weight of 3. We might call it hydrogen 3, but usually we call it tritium. Now, just like with our Lego pieces, usually we don't care too much about what colour our piece of Lego is, just so long as it is the right shape. But sometimes the colour is important. And it's the same thing in chemistry with isotopes. Usually we don't worry too much about which isotope we've got, but sometimes it's important. Now, we can take 2 of our atoms and stick them together. And if we do this, we've got a molecule. Molecules are made of atoms stuck together. This, for example, is a molecule with 2 hydrogen atoms stuck together, and that would make it a molecule of hydrogen gas, of the kind that we use now for powering our new hydrogen cars and trains and buses and things. Or we could take 2 atoms of hydrogen and 1 atom of oxygen and stick them together to make a new molecule, a molecule of H2O. H because it's hydrogen, 2 because there's 2 atoms of hydrogen, and O because it's oxygen. This is a molecule of H2O, and you might realize that H2O is the chemical formula of water. In other words, this would be a molecule of water, the smallest bit of water that you can get. So very simply, molecules are made of atoms. Now I know there's a few smart cookies out there that'll say, hang on, the International Union of Pure and Applied Chemistry defines molecules in a different way. Yep, that's true, but I've got beef with IUPAC, and that's a video for another day.
Why are you doing this to me, you fiend?
Because when I have this...
Why are you talking in that stupid accent?
Because everyone with Drs speak like Russian.
Well, that's just...
Shut up! As I say before, so rudely interrupted. When I have destroyed all scientists in the world, there be no more chemicals, and world be Gwyneth Paltrow heaven. Except for candles, or they smell bad. But now, I disintegrate you to atoms. Or molecules. Which one's the bad one again?
Well, they're both bad, but... Wait! Didn't you watch the video? I just made it!
Gwyneth tells us not to listen to scientists.
You know, chemicals are made from atoms and molecules, right? You wouldn't want to disintegrate me and make a bunch of chemicals, now would you?
Oh, I hadn't thought of that.
How about setting it to homeopathy mode? That way you wouldn't make any chemicals at all. Just set the power to infinitely low.
Great, thanks. Ha ha! Now you die, you scientist.
Yes! If you like this video, then click the like button and I'll make more. And if you subscribe, you'll know when they come out. Everyone's a winner.